Hello, One-Way class. Mr. McHugh here with you. I'm going to wrap up section 9.2, the quadratic formula. As you know, page 4, we're going to focus on a concept here with objective 3 called the discriminant and the type of solutions you might have. Okay, so here's the story. As you know, you've got the quadratic equation says x equals negative b over 2a. You know it's from, of course, ax squared plus bx plus c equals 0. Okay, you got all that. We've been using this. We've been doing some problems, and maybe what you've noticed here is when you see that big radical, the square root, that the b squared minus 4ac really ultimately determines, b squared minus 4ac discriminates or determines. That's why they call it discriminant. Discriminates or determines. I know I shouldn't use the word discriminates, but it does discriminate as to what 4 possible solutions you're going to have. Okay, because you got a plus or minus, and I'm going to show you the 4 different examples here. Okay, so I just want you to understand that the book says b squared minus 4ac is the discriminant, and I ask you to put your imaginary square root sign on top of it to get your brain thinking, because it's plus or minus what is underneath there. Okay, and so let me go through the 4 examples here. I try to set this up here. So these problems, it's to give you a heads up if you wanted to before you solve it as to how many solutions you're going to have here. I recommend that you get these 4 cases, put them in your hand notes, and nail down exactly what the 4 possibilities are here. They're not too bad once you get them done a couple times. Okay, so here's the deal. When you have b squared minus 4ac, if you have a value such as like a positive 9, if you were going to take the square root of it, you would get, your answer would be what? Plus or minus 2 rational numbers. Now, what happens if you do it and you come up with b squared minus 4ac gives you a 10? The square root of 10 is an irrational number. It's not an exact, it's not a perfect square root. Okay? Therefore, you'd get 2 irrational solutions. And I should be writing solutions here when I say numbers. We're talking solutions, because the rest of this, whatever you have up here, you divide by 2a and add negative b divided by 2a. These are all numbers over here. This isn't going to change your value of what you get underneath the radical once you execute the square root. Okay, a rare case number 3 is that rare scenario when you happen to have underneath the radical, the radical is square root, the radical 0. That can happen every once in a while. What that's doing, class, real quick, if I could squeeze it in, is that's the case when there's only one solution because it touches right on the x-axis. Okay, square root of 0 is 0, plus or minus 0 doesn't change it. Turns out to be one rational number. Finally, like the last example we had, what happens if you take the square root of a negative number? You're going to get a complex. You're going to get the I in there, and you're going to get 2 of them, the plus or minus factor. Okay, so that's the idea. And example 4 is on page 509 here. I'm going to go through these here real quick. The idea here is simply take the quadratic equation, put it in the standard form if it's not there. Now on the class notes, they were all in standard form, but I noticed on this new revision here that 2 of them aren't, so I'm going to show that to you here. So I'm glad you're watching the videos with me here. 6 squared minus x minus 15. Pop a 1 up here for the, here's your a, here's your b, here's your c. Assign your values. Stick them into the discriminant is b squared minus 4ac, so this is a plug and chug. plug in the values, do the arithmetic. You get 1 plus 316 is 361. Okay, 361 happens to be, if I ask you to take the square root of it, plus or minus, it's a perfect square root, so you get 2 rational solutions. You're up here on case number 1. Okay, it's 2 perfect square roots. Okay, and that's all your answer on these. It's just identifying what type of solutions you're going to get. Now, example B, if you look in the book here real quick, they try to trick you. Oh boy, they think they're scary, but they're not. Minus 4x equals 5. Okay, here's how the original problem is given to you. Guess what you do? Minus 5 on both sides, and boom, here's your A, here's your B, here's your C. You plug in, you get negative 4 squared 16 plus 60, you get square root of 76, and So what I do, there's the b squared minus, so you take 76, put the square root, put the plus or minus, and what are you going to get? This is irrational numbers. This is case number 2. So you're going to get 2 irrational solutions. Okay. So you get the idea of it. It's just a matter of making sure it's in standard form, get your accurate A, B, C coefficients, plug them into b squared minus 4ac, which is the discriminant, and you do a little arithmetic and you see what the result is. So let's look at case number C. 4x squared plus x plus 1. Don't forget, if you don't see a coefficient in front of a variable, put your 1. So here's your A, here's your B, here's your C. Plug and chug. A is 1. 1 squared minus 4 times 1. Plug them all in, and you get 1 minus 16, and you get negative 15. Okay, now you see it's a negative number. What you could do in your head to answer this, you are taking the square root of a negative number into plus or minus. Therefore, you know you're in imaginary and you got complex numbers. Okay? Yeah, sorry. Okay, we're fine. I'm just got lost there for a second. Okay, example 4D talks about this time in the notes class, I mean on the homework or in the book, they try to trick you again. It's 4x squared plus 9 equals a positive 12x. Move the 12x over, you come up with this, and therefore you get your A, your B, and your C. Write them down, plug them in, and so it's b squared minus, you know the drill, b squared minus 4ac, plug in, and you get 0. Take the square root of 0 plus or minus, and you get 1 solution. That's because you're adding or subtracting 0, and it only forces 1 solution. And that, again, by the way, is your parabola is touching somewhere on the x-axis, just one spot. Okay, by the way, when you have complex numbers up here, I forgot to mention this, I'll squeeze this in. Where's that complex number 1 at? This guy right here, you are going to get a graph. Think about this for a second. We've had 2 solutions, 1 solution. Guess what? When the graph does not cross the x-axis, no solution or no real solutions. Therefore, you get the complex numbers, complex solutions. Okay, so keep that in mind when you see that discriminant is a negative number. You're taking a square root of a negative number. That means your graph will not cross the x-axis. Okay, Mr. McHugh, guess what? We have done it. Let's just take it up to the top here for a second. Good job, everybody. Good work on this section here. Kudos to all your hard efforts. 9.2 is in the books. So when I see you next, we'll start 9.3. Okay, take care. Bye.